Hello, now we'll discuss about demultiplexer in this lecture. So it is also combinational circuit that gives many output from the single input. Again, the output depends upon the combination of the selection line. So here we have only one input in the demultiplexer, and here we'll have outputs that will be to the power n. So this n is the number of the selection line. So here we'll have, and we are going to write the selection line. So let's start with S0 and it will go to the S suffix n minus 1. So total here number of selection lines are how many? N lines. So that is decided by the to the power n here. Now we have taken one example where we are going to design the 1 cross 4 demultiplexer. So since it is 1 cross 4 demultiplexers, so this 4 we can write again 1 cross to the power 2. So number of selection line is what here? 2. So a small n value is 2 in this case. So input will be always high here. So that input we are taking as the 1. Now on the basis of selection line, it has two selection lines. With the help of 2 bits, we'll have 4 combination 0, 0, 0, 1, 1, 0, 1, 1. When selection line is 0, 0, then we'll get D0 as the 1. Remaining are the low. When selection line, we have combination 0, 1. So that binary equal to 1, you can consider this is D1. D1 is 1, remaining are the 0. Again, we have 1, 0. This binary in decimal is 2. So that D2 will be 1, remaining are the 0. Again, we have last 1, 1. So that binary in decimal is 3. So D3 is 1 and remaining are the 0. Like this also we can keep in the mind. So here all diagonal elements are going to be 1. So how we are going to implement this one with the help of logic gates? So here we have two selection line. So selection line we are writing as the S0, S1, and for that we have to take the inverted output. So that inverted output we are getting here. And this is our input, that is always I. So here how many outputs we are going to get here? We are going to get 4 outputs here. So we required 4 AND gates. How many outputs are there in the demultiplexer? That much AND gate is required. So this I is connected to the each AND gate. So AND gate 1, 2, and third one as well as AND gate 4 all are connected to the input data inputs. Now we have to do the selection line. You know that for the AND gate all inputs should be high, then only its output will be the logic 1. So this is the AND gate we are using for the D0. Second AND gate here, this is we are using for the D1. This one we are using as for the D2, and this one we are using for the D3. So when selection line combination is what? 0, 0, then only we are going to get output, that is your D0 as the 1. So here AND gate input should be high. So inverted output of both selection line is connected here to the AND gate 1. Since selection line is what here? 0, 0. So inverted output is what? 1. Next selection line is combination what we have? That is the 0, 1. So as 0 is the 0. So its inverted will be connected to the AND gate 2 and S1 is already 1. So it is non-inverted will be connected to the AND gate 2. So these are the combinational circuits. So that logic array and all this symbol we can't use here. Again, we have another 1 0. So as 0 is already 1. So that's why non-inverted as 0 is connected and S1 is 0. So we have to connect the inverted one that is connected to AND gate 3. Similarly, last one, if you see that we have 1 1 selection line. So both are already 1. So here non-inverted means direct S0, S1 will be connected to the AND gate 4. So on the basis of selection line, if you see that at a time, only one gate AND gate will have output as logic 1. So that's why we are going to get 1 1 as the output here for the different combination of the selection line. The size of the demultiplexer is going to decide how many selection lines will be there. So that we have seen, and finally it is explained, and how many outputs are there. On the basis of that, we are going to decide how many AND gates are required.